Okay, this is part 2 for counting methods. The previous video showed that we could determine how many different ways you could, we could determine how many different combinations you could have if repetition was allowed by taking the number of ways the first thing could land by the number of ways the second thing could land, by the number of ways, say, the third thing could land. So if you have 3 coins that can land on heads or tails, that's going to be 2 ways the first one can land, 2 ways the second one can land, 2 ways the third one can land, and that's going to result in a combination of 8 possibilities. We're talking in this case about order matters. If order matters, then heads and tails and heads is going to be different from heads and tails, even though both of these involve 2 heads and 1 tail. So if we've got 3 coins, we could, and repetition is allowed, order does matter, sorry, then we could have head, 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 or head, head, tail. That's the only way to have 2 heads for the first 2 tosses. If we end up with a head and a tail for the first 2 tosses, the third one could still be a head or a tail. If we have a tail and a head for our first 2 tosses. So we've got 2 ways we could do with 2 heads, 2 ways we could do with a head and then a tail. We will have 2 ways that we could land on the third one if the first 2 consist of a tail and then a head. The third one could be either a head or a tail. What's our other possibility for the first 2? We could have had 2 tails, and again, the third one could still land on a head or on a tail. So we've got 8 possibilities. Now we can't really talk about the way to toss 3 coins if repetition is not allowed. Because if you can't repeat, then the first one could land on a head or a tail. The way the second one's allowed to land would depend on what the first one landed on. And there isn't even a third option. So you can't even toss 3 coins and say repetition isn't allowed. But what if we're talking about, say, we're choosing 3 people, 1 to be president. This is maybe for a club. 1 to be vice president and 1 to be treasurer. Now we don't want the president to also be the vice president because that would be weird, or the treasurer. And we certainly don't want one person to have all 3 positions. So here, it matters who we choose to be president. If we've got Joe, Sarah, and Susie. If for president, we choose Joe, then for vice president, we only have Sarah and Susie to choose from. So maybe we choose Sarah for vice president and Susie. Or if we had Joe be president, we could swap the girls around and let Susie be the VP and Sarah be the treasurer. What if we choose Susie as president? Well, then there's going to be two ways to place the other two. We could have Joe be vice president or treasurer, and Sarah take the other spot. Or if Sarah's president, then there's two ways to place the other two. Joe here or Joe here. Susie here or Susie here. So we've actually got 1, 2, 3, 4, 5, 6. Now, if Joe is chosen, well, whoever is chosen for president, we have 3 options to choose from. However, since we cannot have any repeats, no matter who is chosen to be president, we now only have 2 options to choose from for vice president. And since we now have 2 of these people chosen for the first 2 spots, that only leaves us 1 person left to be treasurer. And notice if we say 3 times 2 times 1, we do get 6 as our total number of combinations. If repetition is not allowed, you can still get your choice, get your number of combinations by multiplying. But in this case, it is not independent, because whoever is chosen first, that determines who is left to choose from for the second position, which determines who's left to choose from the first position. Let's say we had 5 people to choose from, but we're still going to choose 1 president, 1 vice president, and 1 treasurer. How many people do we have to choose from to be president? Well, we actually have 5 people to choose from, right? Having chosen one of these 5 to be the president, how many choices do we have for vice president? Now we're down to 4. How many choices do we have left for as treasurer? We only have 3. What about the other 2? Well, they get to sit back in the audience. They don't have anything to do with this. If we have 5 and we're going to choose 3, and order matters, we have 5 times 4 times 3 possibilities. 5 times 4 is 20, times 3 is 60. Given 5 people, there are 60 possible combinations we could have as president, vice president, and treasurer. Now that's a big jump from having 3 to choose all 3 of them. In the previous option, we had 3 and we're going to choose 3. That only gave us 6 possibilities. So it makes a huge difference. So these are not independent events. Order does matter. It matters who we choose to be first, who we choose to be second, and who we choose to be third. So this is still very similar to the way you can do it when they're independent events. You still take the number of possibilities for the first spot times the number of possibilities for the second spot, which could be the same as before, or it may be different. And then the number of possibilities for the third spot, and so on and so forth. So this is how that works. You just have to picture what's going on in your mind and ask yourself, how many possibilities do I have still to choose from for this second event and the third event and fourth and so on. Now there are formulas that we will be learning to do this, but this is basically how it works, and you can always fall back on these to figure it out.